Sometimes when you are in offshore barge or vessel, you may experience a position jump. If the jump is small and for a smaller duration, you may not even notice it. And sometimes the position jump is big and for a longer duration. And these position jumps can have a serious effect if you are doing some critical operations. Similarly on shore, if you are doing a GPS or RTK survey, you may find a position mismatch after final processing. So today I will tell you why this is happening, how will you know that this is ever going to happen, and what you can do to mitigate this problem. If you are new to my channel, welcome. If you are an offshore surveyor, you can hit that subscribe button and join my channel. And if you have learned something from this video, then give me a thumbs up and buy me a coffee by clicking on the thanks button. So why this is happening? Our sun is a huge ball of electrically charged hot gas. This charged gas moves, generating a powerful magnetic field. The sun's magnetic field goes through a cycle called the solar cycle. Every 11 years or so, the sun's magnetic field completely flips. That means that the sun's north and south poles switch places. Then it takes another 11 years for the sun's north and south poles to flip back again. The solar cycle affects activity on the surface of the sun, such as sunspots, which are caused by the sun's magnetic fields. As the magnetic fields change, so does the amount of activity on the sun's surface. Giant eruptions on the sun, such as solar flares and coronal mass ejections, also increases during the solar cycle. These eruptions send powerful bursts of energy and material into space. This activity can have effects on Earth. For example, eruptions can cause lights in the sky called aurora or impact radio communications. Extreme eruptions can even affect electricity grids on Earth. These charged particles migrate to mid-latitudes and make a cluster in our ionosphere. They change the normal elements like air and water molecules in our atmosphere with additional electrons. In short, the TEC or total electron count in the ionosphere increases. This cluster of charged particles or cloud move from east to west, and they will appear exactly after 24 hours on the same spot. It takes some 10 to 15 days for this charged particle to dissipate. Any radio signal or signal from the GPS satellites coming through this cloud of charged particles will experience significant delay, or sometimes they even does not pass through. Most recently in last February, there was a radio blackout in North America due to this phenomenon. A big CME struck Earth as recent as on 24th of March 2024. So the next question is, how do I know when this is going to happen? You can visit www.spaceweather.com to keep a track of what is happening with the sun. You can get a solar flare alert as SMS text in your mobile if you subscribe to Space Weather with a small fee. There is another option. You can go to www.gnssplanning.com. Go to the settings, select the equipment capability of satellite reception, like if your equipment can get only GPS, then tick that option and untick the rest of the options. Select your latitude and longitude. You can do this by clicking on the map also. Select height of your observation point and keep GPS elevation cutoff at 10 degree. Select the day for which you want the prediction and then select your time zone. Click apply. Next, go to Charts tab, which will show you elevation of satellites, total number of satellites, various DOPs, satellite visibility times, and lastly, the ionospheric information. In this chart, you can see the graph of total electron count in the atmosphere above your location. The scintillation period is given in dotted line. This is generally a good indicator for you to decide when is the best time to do a GPS observation and when is the worst time to do any critical work. Now let's go to world view. Click on the TEC under Ionomap. This takes a few seconds to load the data. Once the data is loaded, you can click on the play button to see how the charged particles are moving. My suggestion is that you try to avoid any critical position based operation when the yellow, red and pink cloud is over your location. You can click on the scintillation to observe the active scintillation that is happening. Now the active scintillation may not move the way TEC cloud is moving, but any period of active scintillation above your location must be avoided for any critical work where GPS position is required. So the next question is, what can you do to mitigate this issue? Because in offshore you simply cannot wait for the space weather to clear up as per your requirement. The best possible solution is to carry a G4 system which is capable of receiving all the satellites from America, Russia, Europe and China, and make sure that your equipment is capable to receiving differential correction for orbit and clock. No matter what, a sustained scintillation over your survey region will produce a bad position data even with all the latest technology. It is very important that you know what is going to happen and make client understand that this is beyond the capability of any modern technology as of now. And remember, this phenomena will continue throughout 2024 and 2025 as we reach solar maximum in 2025. And after that, it will slowly wane off by the end of 2026. So we can say that there are two reasons we should be looking up to space weather and GNSS planning. You can prepare for a showdown of a beautiful aurora in the night sky and at the same time prepare for GPS position jump and mobile and radio signal disruption. Tell me, have we learned something today? Be curious and be aware of things happening around us all the time. I'll see you around.